something called a condenser. After the condenser, we'll have a platform where we'll keep our specimen. Then we have objectives. And then we have an eyepiece from where we will see. It's called an eyepiece. So when the light comes from here, light condenses in the condenser. It condenses the light. Light will hit the specimen, and specimen then will be seen by an objective, and objective will go to the it will carry the light, and we'll see it from the top with an eyepiece. We'll see from the top. We'll see from the top, and we get some impression. So the image quality depends upon the eyepiece. Eyepiece is always 10x, as I've told you, 10x objective. Eyepiece and objectives can vary. It can be 4, it can be 10, it can be 20, 40, or 100. So depending upon what we are using, it can be 10 into, when we look at 4 or 10 or 20 or 40 or 100, because we use 10x and 20 objective, the magnification will be around 200. Or in case we use 10x and 40x objective, the magnification will be 400. X we call it. So that's the way we work. And here, what is phase contrast microscopy? Till some time back, we had bright field microscopes. They were called bright field microscopes. They were upright microscopes, and these microscopes had only one small issue, that it could only see stained specimens. In case we could stain something, we could see it well. So whatever we put, suppose we take a slide on which we put the specimen had to be, and then the cover slip. The specimen had to be stained. So it could difficult to see with this microscope unstained things. So it could see basically color. So in simple terms, it could see color, and with the color we could see the objects better. But when we stain, then the object, the specimen probably is a dead specimen. So specimen is a dead specimen. That's the issue by using a bright field microscopy. So here staining was important, coloring was important with the staining, and we could use thin specimens, and they actually died when we stained. Them. So not all of them could, until it's a supervital stain, they all died. So this microscope is not very essential, important for us, because when we work in the ART lab, we work on live specimens. So this microscope is not of much utility in our setups, because here we are working on semen sample or some other samples which have to be alive, because we have to use them later. So then came the concept of a phase contrast microscope. So in the phase contrast microscope, what they did was they put, I will just take you through this. Here we had in the simple microscope, we had a light source below, and then we had a condenser, and then we had a specimen, we had objective, and we had an eyepiece. Now, when we go to the phase contrast microscopy, what they do is that here also we have a light source, then we have a condenser. Above we have the specimen, and then we have objective, and above objective we have the eyepiece. So this is very simple to know and understand. This is a upright microscope, which is a bright field microscope. Now what we do is, this microscope, we are putting 2 rings which will create contrast. So we take a disc like this, we take a disc like this. So this disc is something like this. This is called the annular disc. That's the way it is created. So this disc will have this such a disc is, so this is opaque. This is and these are opaque, and the light will only travel from here. So we put this disc something like, it look like this, in case you now see the disc, it will look something like this. It looks something like this. In case you see the cut section of this disc here, and we put such annular disc, we put one along the condenser, and we put one in the objectives. So this will create contrast. When the light is passing from below, light will pass through these discs, which will block the light in these areas and allow the light in these areas. So we put two of these discs here. This is called the phase disc, which is put in the objective. Then we have got the annular disc, which is put up in the condenser, along with the condenser. That makes the microscope, with two discs coming up, it makes the microscope a phase contrast microscope. This is a simple way the microscopes they work, and this is called a phase contrast microscope. This we use basically for andrology, and the price I've told you, it varies. The price varies between rupees 40,000 to rupees 2 lakhs for the top quality phase contrast microscope, which we use in IVF. You buy it from Nikon or Olympus. Now we go to another microscope that is called a stereo zoom microscope. A stereo zoom microscope. This microscope has got a quality that here we don't see a slide. We don't work on slides. We work on big objects. We work on big objects which can be actually seen by the eye also, but this will magnify the image. Here we have big working area. In stereo zoom, in a phase contrast microscope, there is no working area. I'll show you the pictures. The gap between once you work on a phase contrast microscope, the space between the specimen and the objective is so small that we can only put a glass slide there. Otherwise, we cannot operate there. Stereo zoom is sort of an operating microscope. It is an operating microscope. It's also called an operating microscope. Here we can do small surgeries on the specimen. We can cut the specimens, we can dissect them under our vision, under the microscope. So here we have we have something called light source. Then the light directly goes up. Then we have got objective, and we've got two prisms which are put here, and then we've got an eyepiece. So it gives you very less magnification. So the magnification and eyepieces as regular are always 10x. So there are planar objectives here, but we have an assembly called zoom assembly. We call it a zoom. So zoom will start from say 0.4 and it will go till around 11.5 approximately in a good microscopes. So the magnification within stereo zoom microscope will be say 10 into 0.4, it will be 4x, or maximum say around 11 to 13 depending upon case you want to spend a lot of money. But normally it will be 10 into 2, 4, 6, 8, 10, 11. So whatever we do, in case we use 10 or 11 also, we don't cross magnification of 110x. But in case you go to the phase contrast microscope, as I've showed you, the magnification is on average 100x. It can be 100x, 200x, 400x, or 1000x. The magnification is very high in the light microscope or phase contrast microscope, But in stereoscope microscope, the magnification is pretty less. This you have to know. But it's got a big aperture. It's got a big opening for light to come. The objectives are big objectives. The light source is a big light source. And when we see from the eyepieces, it's got a big objective, a big aperture also. So the image looks bigger. The image is seen properly, and we can actually take some sort of a needle and we can take some scissors, or we can actually cut eggs. We can operate upon the eggs. We can operate upon the some type of cumulus cells. So stereoscope gives us that advantage of surgery, though the magnification is a maximum of 100 to 110x, but it gives us the advantage of operating, which is not available in a phase contrast microscope. So the third type of microscope which we use in our practice is a inverted microscope. As you can see here, in inverted microscope, we got a different assembly. Here what we have is, we got the light source, which will give the light. Then we have got condenser, where we have the condenser. Then we have got the specimen, and then below the specimen we have got the objectives. We have got the objectives. Then here we have got eyepieces, eyepiece, and then that's the way they work. So here the advantage is that we have a big operating space here, like we had in a stereoscope microscope, but the main difference is that the objectives here are mounted below. In both phase contrast, as you see in phase contrast, the objectives are placed above and light source was below. So in the phase contrast and stereoscope microscope, we had light microscope, the light source below. Here the light source is on the top. The condenser is also on the top as compared to the phase contrast and stereoscope microscope. So here the microscope becomes inverted. So that is a big advantage of inverted microscope, and it also has an eyepiece. As I told you, the eyepiece here is also 10x, and it will have objective of 4x, 10, 20 or 30. So the magnification here given is also the same magnification which we get in the phase contrast microscope. But here we can actually operate, we can carry out ICSI, it gives us better contrast and better visibility. So advantage of phase contrast microscope, as I told you, is that in the phase contrast microscope, we get very high magnification, but we work on glass slides. We mount something on a glass slide, keep it there, and we cannot operate upon that. It is only for viewing, and we can see things without staining them. That's the advantage of a phase contrast microscope. But when we go to a stereoscope microscope, we can operate there. We can operate upon some oocyte cumulus complex. We can cut them. We can cut the cumulus. We can do very, very small surgeries with small needles, and the magnification here is low. The maximum magnification which we get here is around 110, but all the routine microscopes will give you magnification of around 70 to 80x only. But it's got a big operating distance. We can actually manipulate things under the vision, and the advantage is that we can keep zooming in, zooming out, enlarge the things, make them small. Stereoscope microscopes is a very fantastic microscope to work on. And inverted microscope is always mounted on a micromanipulator, and we can put very fine needles, syringes by which we can do ICSI, catch sperms, operate upon these sperms, operate upon the eggs. So magnification here is also same as phase contrast microscope, but it works very well. So now coming to today's topic. What do we do in IVF? In IVF, our main aim is maybe IUI. Our main aim is using some sort of medias. We use these medias and different type of medias we use, and we use some sort of plastics and the media droplets we make under oil. And the main aim is basically handling the OCG complexes. So as you can see here, we get the OCG complexes, and here. So can someone tell me what type of microscope? Now I think I've already covered. Now I'll try to make it more interactive. What type of microscope we work on when we are working here? Anybody?
A stereozoom microscope.
Stereozoom microscope. Stereozoom.
Very good, very good, very good. So it is the stereozoom microscope, as I've rightly brought out. So to do this sort of work, we have to work on a stereozoom microscope. We can also work on inverted microscope, but inverted microscope is more cumbersome for this. Can we do this sort of egg hunting or in a phase contrast microscope? Just keep talking. I want all of you to get involved now. We have given you the basics. Now it's only pictures and some videos. So do you think that we can do this sort of work, what we are doing here, on a phase contrast microscope?
No.
No. Why can't we do?
No.
No.
Because
Okay.
phase contrast we cannot
Stain.
we cannot stain the inside.
Staining.
So what are we doing here? What procedure are we doing here? Can someone tell me? I'm going to educate everyone. Can someone talk for a few seconds? What
OCC complex. I mean, denuding like.
ये हम लोग
is a harvesting, or we also call it Supriya. Yes, Supriya wants to say something.
So we are collecting the oocytes, probably washing them.
Yes, very good. So you can see these beautiful OCCs, and you can see these eggs here. These are the oocytes, and this is the whole thing is the OCC complex. So here, when we work here, we have to use a stereozoom microscope, and that's the way the things work with them. It's very nicely you can work on these OCC complexes, count how many you have picked up, and this keeps our job simple. So this is what we do on a stereozoom microscope. So in case somebody asks you, why do we need a stereozoom microscope? We need stereozoom microscope for this particular thing. So after we have collected the stereozoom microscope, we have done the OCC complex hunting, we wash them and we keep them under oil droplets. And these are the OCC complexes, and then we carry out insemination. So insemination we have done, before insemination we have to prepare the semen sample and see it under a microscope. This is the pre-wash semen sample, and this is a post-wash semen sample. So can someone tell me what type of microscope we use for looking at these sperms?
Simple microscope.
Simple microscope.
Simple microscope.
So this simple microscope is a wrong term we are using now. So this is what I'm trying to tell you guys. After you become alumnus of IC, even with the one class, I can assure you that not many people in the country will know more than you about the microscopes. So now I've given you the basics. Now you have to take the initiative and give me the right appropriate answer. So what type of microscope is this?
Inverted type.
Phase contrast microscope, sir.
Why phase contrast?
So we can stain these sperms in these kinds of microscopes, and slides are prepared.
So Supriya, the thing is that when we use a phase contrast microscope, it is done for a live specimen. Remember this. When you want to work with a live specimen and you want to work in black and white.
Okay.
Yes.
So for staining of sperms, when we don't see under this microscope.
Phase contrast. Phase contrast only we use. Whenever we
to learn the morphology of these sperms, we are using phase contrast microscope.
Yeah, phase contrast can give you color also. And your answer was a simple microscope. So that answer was incorrect.
Okay.
You get my point?
Yes, sir. Yes.
Phase contrast we use in IVF or IUI because it can give contrast. It can contrast, enhance all these forms. Can you see these things? Contrast is coming. gives you a 3D view.
Yes, sir.
See, when we use these sort of disc, I drew these discs for you, no? I showed you these discs. So how many discs we use in phase contrast? How many discs are we using? I just told you like this.
So one disc, one
Two.
annular disc.
Two.
Two.
We use two.
Okay.
So when the light goes from here, it comes out from here. So when the light is moving, now listen. Now when the light is moving, light moves like this. Okay. Then when the light will hit this disc, then what will happen? The light will go change the contrast. Light will change the contrast, and the change in the amplitude. Change in amplitude will be converted into change in phase of vision. That will be converted. So the amplitude changes. So the direction they change. As a result, it gives a more contrasting image. Whenever we are working in an IUI or IVF, we are looking at live specimens which are unstained. Also see colored specimens which are fixed and stained. But suppose you want to do HOS testing. Have you ever done HOS testing? Anybody? Can someone tell me what is HOS testing quickly? Yes, tell me.
Sperm survival.
Yeah.
Sperm survival.
So in HOS, do we stain? In HOS screening, do we stain or not? In HOS, do we stain?
No.
Are we yes or no?
No.
No.
No, we don't stain. Now, in case we are going for eosin, microsin staining or eosin staining, do we stain?
Yes, sir.
Yes.
Yes, very good. Here we are staining. So we have to know what type of procedure we are doing. See, I want all of you to get involved in this program. It's a fantastic program which Pooja and we are doing for you today. Take advantage and clear your concepts. So in case somebody asks you in the future, what type of microscope to buy? It's always a phase contrast microscope. Why phase contrast? Because it's got two annular rings. Where are the annular rings? They are in the objectives and in the condenser both. How do they work? They convert the change in the amplitude into change in phase. Okay, but they can also show you stained specimens. That's always there. Okay, now I'm coming to, so this you have told me very beautifully that here what we are working is the phase contrast microscope. Now we are carrying out another procedure. So can someone tell me what type of microscope we are using here? Quickly.
Inverted microscope.
Why do we use inverted microscope? Why we are using inverted microscope?
We have to work for 𝙊𝙧. This is 𝙊𝙧 procedure, so we have to do some work, sir.
Okay.
Injectable. I mean, injecting sperm inside the oocyte.
Yes.
That's why we required inverted microscope.
Can we do it under phase contrast?
No, we cannot do it. We can do it under stereo zoom, I think.
Stereo zoom. Can we do 𝙊𝙧 under stereo zoom? Anybody? Can we do 𝙊𝙧 under stereo zoom microscope?
We can do it, sir.
𝙊𝙧
complex.
𝙊𝙧.
Yes, sir. As you told, sir, we can do microsurgery. So can we do, sir?
No, we can't do 𝙊𝙧.
No, because we cannot attach the needles and everything.
Yeah, the magnification is not so much. The magnification of an inverted microscope, the operating area is the one which is available in an inverted microscope that we don't have in stereo zoom microscope. Stereo zoom microscopes, you can do small surgeries on the OCC complex. So in case you want to operate on this, we want to operate on this for the stereo zoom microscope. In case you want to operate on this cell, which is a big cell, operating upon a big cell, or a OCC complex, we can operate on stereozoom microscope. Suppose we do TC. Has anyone seen TC being done, TISA being done, or surgical sperm retrieval being done?
Yes, sir.
Where do we work? Which type of microscope we use there?
Stereozoom microscope, sir.
Stereozoom microscope.
Stereozoom.
Yes, it's a TC. But when we have to operate upon the sperms, what microscope we use? When the cells are very
Inverted.
When the cells are very small and you want to operate, we go to very high magnification. Then we work on inverted microscope. When cells are big like this and you want to operate, under stereozoom you can only operate upon big cells. In inverted microscope, we can operate upon eggs and sperms. But here we are operating upon OCC complex. So stereozoom is for big cells, and for very small cells and for injections and ICSI, we use an inverted microscope. Okay, this is the thing, and this was the small video. This is being shot, and here we are working on an inverted microscope. You can see that how beautifully the contrasts are being generated, and we are injecting the sperms in these cells. Can you see the sperm moving here? Can you see the sperm? No?
No, sir.
No? Why? Sperm is here. Follow this. This is a sperm.
Yes, sir. Now.
It'll come back now. Now we are aspirating. Now sperm we have aspirated. Now the sperm will go back, and gradually sperm will go back in the end. So yeah, now the sperm is being, this sperm has been deposited now. So we have separate around 8 hours or 10 hours programs on ICSI, cryo-freezing. This is just an overview. Now, you want to do some embryo grading and change the embryos from one dish to another dish. What type of microscopes will you use?
Stereozoom microscope, sir.
Stereozoom microscope. So wherever you want to do manual pipetting, What is this? Can anyone tell me what is this?
Stripper.
Stripper. Very good. It's a stripper. So whenever you want to do things manually using a stripper in these plates in the media, this is called stereozoom microscope. Okay, very good. So when you want to shift these embryos from one plate to another plate, we use a stereozoom microscope. It's only for shifting. But when you want to operate upon them, you want to do biopsy and take out one cell. Then which microscope will you use for biopsy?
Inverted.
Inverted.
Microscope.
Inverted.
Inverted microscope.
Very good. Very good. So does anyone has any doubts still here? Anyone would like to ask me something? Anyone would like to ask me something here?
Sir, can you please explain briefly about phase contrast microscope, sir?
I'll explain, madam. I'll come to the pictures now. I will explain.
Okay.
I will explain everything to you. Don't worry. I'll explain everything to you. But till now, are you clear about what I have told you?
Yes, sir.
Are
Yes.
you clear? Is everybody clear? I have.
Yes, sir, it's clear.
Good. I'm so happy.
Yes, sir. Yes.
Okay. So let's see. We have with us now 14 participants. So I'll ask all of you one by one. Are you clear with the things or not? We have Dr. Pratyusha in the top. Are you clear, Dr. Pratyusha, about the talk?
Yes, sir.
Very good. Dr. Adita Afzali?
Yes, sir. Yes, sir.
Clear? Very good. See, sometimes our language, our communication may vary. You may not be able to interpret our language. If you have that problem, do let us know. Dr. Pandit, thank you. Thank you.
Yes, sir. Yes, sir.
Dr. Pandit is clear. Dr. Emmanuel, are you clear? Clear. Very good. Very good. Then we have Dr. Abdul. We have not met Dr. Emmanuel. No, Dr. Emmanuel, from where do you come from? Which part of the world you're from? Tell people about you.
I am from Ghana.
Ghana. Very good. Very good. So you're doing IVF or something there, or you are a beginner, or you are training?
Yeah, I am an clinical embryologist.
Wow. Very, very nice. Very, very nice. Thank you.
And-
Welcome to our group.
And sir,
Yes.
I also want to add about Dr. Animil. He is from Ghana, and we are 5.5 hour ahead from Ghana. And he is attending this time. It might be 6 a.m. in the morning in his country, and he's so dedicated. He get up early 5 a.m. and he joined us. So thank you so much for joining us.
You're welcome.
Okay, okay. So Pooja, can you introduce other people also? We can say hello to all for a few minutes. The people have joined late.
Yes, Dr. Kalpana has joined late. Dr. Kalpana, can you introduce yourself, ma'am? Please come on your camera for a few seconds. Okay, and we have new joining Dr. Ashok Patel with us. So he is also
Okay.
with us. Dr. Ashok,
Okay.
can you introduce yourself with us? We have Dr. Whosoever has not introduced, can you please, Dr. Nara, he was about to introduce and he came on the camera, and by the time we started the talk, so Dr. Nara can introduce them. Hi, good
Hello.
morning.
Hi,
Hi, how are you?
I am from Mongolia.
Mongolia. Okay, lovely. Okay, great.
Okay, I'm clinical doctor, and I was working clinical embryologist over 1 year.
How cold is Mongolia? Very cold?
There is -7 Celsius.
Wow, can you show us the background? I would like to see how Mongolia looks.
It's
Okay,
snow.
it snowed. Okay,
Snow.
lovely, 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 lovely. Very beautiful, very beautiful. Thank you so much for joining us, and I hope we make a difference in your lives, and you will also make difference in our lives. Thank you so much for joining
We have
us.
Dr.
Thank
Abdul,
you.
and Dr. Abdul is also from Ghana. So he is also, he has joined us very early morning from Ghana. And this is all. I was just, now we can just continue the session.
Should I go ahead?
Yes, sir, please, sir.
Okay, thank you.